What? Okay. Are you gonna fall asleep? No. No. And if you want to, okay. So this all came to be because our professor wanted a masking model in 1/16 for Studio, and I decided to 3D print mine for the midterm or the mid review, and everyone was jealous because it looked so good. And now I'm giving a lecture to everyone else that wants to know how to do it, because nobody teaches how to 3D print in the school, and we have like 8 3D printers, and I have my own at home, which is a really fun hobby, and I've learned to shit post in real life now, and it's really fun. And I make all kinds of fun stuff, and I want to share it with you guys. So, what is 3D printing? 3D printing is plastic. So there's different types you can get all of the material. The most common is PLA, which is made up of corn. It's completely recyclable, biodegradable. It's good for sustainability. But there's other types like PETG. There's types of plastic with metal fiber, carbon fiber, wood fiber. There's silicone. There's all types of stuff. There's glow in the dark. There's multicolor. It's infinite. All the colors of the rainbow. Obviously, different types of materials take different requirements for your printers, but basically at school, the printers here use PLA, which is most common, and which is the only thing you really need to worry about. So how to start 3D printing? You need a software that can create a 3D file. So SketchUp, Rhino, Autodesk has a Fusion 360, and there's 20 other ones, and they just get more and more complicated. But everyone knows how to use SketchUp and Rhino, or AutoCAD can do it. It's a little bit complicated. I'm not too sure how to do it, but it is possible. So when printing something, there's a lot to consider. It's not too terribly complicated, but you can mess up pretty quickly and it can ruin your projects. So on screen is an image of 2 test items. So on the right is a boat. The idea is that it shows, there's actually a lot you can do with this boat when you're printing to calibrate your own printers, but the school printers are already calibrated. People know how to do it. They do it for you. So it's ready to use whenever you use them. But it is still an example of the limitations of a printer. And on the left is a better example showing bridging, printing over air, printing over different degrees. So you can print how far can you print the overhang, what angle, and then stringing at the very top, you can see those tall towers and how it strings between the two, which is a feature that you can use. Do you actually have a question?
Yeah. Do you have an example of something you can print? Or like, what is something that's like too complex for the 3D printer that it can't?
So things that are, that's a really good question. Things that are really, really intricate, and it depends. There are printers that can do it. So there's different types of printers. Like a resin printer prints, it takes a laser beam and it like heats up our resin and makes it solid, and it prints in a vat of liquid. That can print super, super detailed things as long as it's supported. That like normal plastic PLA filament printers can't do, or a sand printer. We have one of those as well. They can't do. So you can print super detailed things, but it just depends what printer. The normal printers here at school, you probably can't do that. Detailed, like super, super detailed, skinny beams or trusses can't do too well. You're welcome. So in any 3D software, as long as you're using a program that loads 3D files or you model 3D, you have to save it as an STL, which is a stereolithography file, which is what can be read by Slicers, which is the program that interacts with a 3D printer. Super simple. As long as you can export to this file in just about any of the 3D softwares. What is a slicer? So Cura is the most popular slicer. It's what the school uses on our cloud, and it's really simple, easy to use. It comes preloaded with all the printers that exist right now and the settings that they need. And that is how you can put your 3D models from your 3D software into this to get them ready to print. Yep. Yes, it's free. It's just a software you download. You can create an account. There's no need to pay for anything in it. And you just can change settings for your printers in it. So before we get to that, let us look at an example. So this is something I quickly made in SketchUp. It's a little house. It has windows. It has an overhang, like a little front porch area. And I have two versions of this, one with the walls like this, where you can't see inside, and one where you can see inside. And we'll look at both of those. So I've preloaded one into the slicer. This is the one without walls. And what you can do here is so when you open up your slicer, it's going to look like this. It's an empty workspace. And the first thing you have to do is select the printer that you're going to use. So at in the 3D lab, we have 5 or 6 Ultimakers, and then 2 Ender 5s, and then the other ones I don't know how to use. But the Ultimakers are super simple. They all have the names on them to some extent, or the lab techs know what the names are and will tell you how to use them or what they are. And then all you have to do is come up here in the top, add a printer, and then Ender Ultimaker, which is the top thing that comes up because it's one of the most popular printers right now. It's all the options for all the different types of printers. You just pick the right one. Right now, the big printer, the first one in the lineup, is the graphite printer, and it's an S5. So I already have that selected here. The first step is this here. You have to match the nozzle that's on the machine to the nozzle that you're using in your slicer, because eventually when it goes to print it, it's going to change all the settings, because that's how much filament come out of the machine at one time. So to figure that out and see where that actually is, right here is the extruder head on the machine. And when you take this front panel off, it's just connected by magnets. You can just unclick it super easy. You can see the 2 extruders here. The S5 has 2 extruders, so it can dual extrude 2 materials at once. A support material and a solid material, or it could do a solid and a clear for glass at the same time as you're going up, or anything you want transparent. We have transparent filament to an extent and solid filament. So you can dual extrude different things or for supports. And then something else to look out for when you're starting to print is filament spools. They're on the back. When we get to the slicing part, it tells you how much material it's going to use. You have to make sure that the spool on the back of the machine has enough filament to print what you're going to print, or else it will, I'm pretty sure they automatically stop when they run out. It has a detector for that. So it won't let you print nothing, but you're also going to waste your time by printing nothing because it will stop. So back to this, once you have the nozzles selected correctly for each extruder head, you can come over to the settings on the right. This is how you can change everything, every little detail about the printer, how fast, how high, position, temperature, everything. When it comes preloaded with the settings for the machine, those settings work pretty good. There's no need to really change those. The school printers are set up in a way to use those factory settings the way that they're already there, so it just works to your benefit. The only thing that to come in here and really look at when you're doing something is supports. Supports can be necessary or unnecessary, or kind of hard to figure out sometimes. So supports is a material that's generated less dense than the actual material of your project, so it's easier to break apart and you can rip it off, but it also supports it as it goes up. So if you're doing overhang for something, you can have a support that comes up to support the material, so you're not printing over air. You might need that for some cases. Say you have a figure with his arms out, you're gonna need supports to hold up the arms, because you can't just print over air the width of his arms. That's really the only thing you need to mess with in the settings. Everything else should be fine. Oh, and infill. So infill, I'll come back to in a second because I have an example for it, but that determines how dense the printer will print inside of a solid object. So looking at my first example, this is the object from SketchUp that we exported through the STL file. And then to import it, you can just click up here in the file. It'll bring up your files. You just find it, and then you can load it into your slicer. The grid on the bottom of the workspace is 1 centimeter squared. So every square is a centimeter by a centimeter. That's one way you can measure your projects, or you can set them in SketchUp or Rhino or your whatever 3D modeling you're using. You can set the scale there. And as long as your scale is in millimeters, it should translate over to this. All the slicer works in millimeters. So that is something important to know. When you click on an object that you put into the slicer, there's your toolbar on the left here. So you can move it, you can scale it, you can rotate it. And then these two aren't really used for anything that we need to be doing right now. And then this is a support blocker. So if you do use supports, but say you want to support something, when you generate supports, it generates them all over the project. But you might not want support inside your building and you do outside. So you can block the supports from like spawning inside. So that way you can control where the supports are, where you might not actually need them, and it will save you time on the print and material. So I've already sliced this one. There's just usually a blue button right here that says slice. You press that, it loads, it renders how long it's going to take depending on the size of your project and how much material you're going to need. So it does all that for you, gives you all the information. It's super easy to figure out. A spool of filament has 1 kilogram of filament on it. So it's super easy to divide by however much it says here. And this is a really big project right now because the printer that it's on it's a big plate. So like I said, the 1 centimeter squared grid. So this one is going to take 12 hours. We can preview it and it'll show you every single layer by layer. The colors have meaning. I forget where to see them, but they have meaning. Yellow is a top surface, red is a side surface of the little strand that comes out. Blue is your adhesion to the bed where your raft or your brim or whatever you select will be. I think it's set to brim, which is what is showing here. And you don't need to change that, that's fine. And then the blue in the project, these are supports. So you can see it's generating a support to hold up this window. The space is big enough that you don't need supports here. So if you wanted, you could go to support, turn it off, and then you could reslice it. It'll reassess how long it's going to take, and then it'll give you another time. So just taking the supports away, it saved you 1 hour and 6 minutes off your print. So it's less material printing, but it's printing over air. So you are taking the risk that it might not work, but this you can see that it's going to work. Like I said, you can zoom down every level so you can see what each layer looks like. You can see what the inside looks like. If there's going to be any problems, you would point them out here and realize what they are. And you can also, it looks cool. So it's fun to do. My next example is this one. So this one is more infill and less structure. So for any of the massing structure or massing models that your professors want, this is a good way to do it. So it's a solid block. You can't see inside, but it's easier to print and less risk. So this one, if you look at preview, I've changed the infill to 10%. So it's less because you don't need more. It's one big mass. And you can see inside, it's all full of filament going back and forth. And you just get the outer facade is what the end result will look like. And typically, well, it depends on how much you infill, but typically it will take less time than doing super detailed walls and interiors in your projects. Uh-oh. All right. Don't do this. So when you're printing, one of the key
key moments of your print is the first few layers, making sure that it sticks to the bed and that nothing messes up on that first view, because the first view will determine the rest of the whole print. It could be off somehow, the extruder could be too low, and it could be digging into your print as it's printing and pop it off the plate, and you've wasted your time. If it's a 12-hour print, you hit go and you walk away. 12 hours later, you come back and it looks like this. The other day, this happened to somebody in our studio, and they created a mess and in the process broke one of the machines because they started it, it looked fine, and then overnight it literally exploded. So don't do that. It's a very slow growing explosion, but it still breaks. So a good tip is to, when you start it, wait around for 5 minutes, wait for the machine to start and actually print it, watch it, make sure the first layer goes down. Then you can leave. If you can, come back a little bit later, check on it periodically whenever you have a chance. These projects can go anywhere from 4 to 2 days, 4 hours to 2 days. So just, if you can, just check on it. It's nice for you to make sure your project's actually printing, and it's nice to not waste and break machines. Another thing is you can easily print multiple things. Do it on the same machine, because that way your settings are always the same. You're not printing on different machines and the settings might be different. But print on the same machine, you can print your project in parts, and then you can super easily sand it and glue it together. It might not look seamless, but it might save you time in the long run. And if you're printing something that's going to take 2 days, you can print it in parts and know that those parts are finished, and you're not a day and 4 hours into it and then it decides to fail for whatever reason because it can't do something. So another thing that is super useful and that you can use is there's websites out there that already have projects by other people that you can use, like furniture or stairs, or like, I don't know what, you could use anything. You can put holes in your project to hold it together instead of doing it if you want it, and if you print it, or you can just go buy hardware. Or you can make fun scale models. You can make little people to put in your project, and it's fun, and school will probably let you do it. And fun fact, you can actually print a 3D printer if you wanted to. It's possible. But yeah, I think that was most of what I wanted to say. Yes. No, it works. You can literally print a printer and then buy the hardware, and you can set up your own 3D printer. Any other questions? So far, so good? Okay. 3D printing is really fun, and it looks really cool, and it does all the work for you. You can build a model in 12 hours while you're sleeping, and you can wake up to a fully built model. And it just takes a little bit of work that you've already done in SketchUp or Rhino or AutoCAD. For your drawings, you just take a little bit of time to delete all of the details and have your structure, and you can print your project. And it's way easier than laser cutting and gluing and all this craft stuff, which is fun. And if that's what you want to do, you can do that. But yeah, that's my lecture.